Good morning, everyone. Today we're going to be looking at triangles, and this is a start to chapter 4 of our book. And when we are looking at triangles, the first thing that we're going to look at is how we classify triangles. And there are two different classifications that we tend to use. The first has to do with angle measure. In those, there are three options. A triangle is either going to be right, obtuse, or acute. Now, if it's acute, what it means is that all three angles of the triangle are acute. And you can see that in the picture that each of these angles is acute or less than 90 degrees. When you're looking at an obtuse triangle, all it means is that one of the angles is obtuse. So one of the angles is going to be greater than 90 degrees. That means that the only option left is our right triangle. And our right triangle is one that contains a right angle. So you have one right angle, or one angle that measures 90 degrees. Don't forget, they often won't tell you that it's a right triangle. They're just going to give you that little square in the corner that tells you it's 90 degrees. With a right triangle, they're also going to use two other terms. The first is one that you might be familiar with, and that is the hypotenuse. The hypotenuse is going to be the side that is opposite the 90 degree. So whatever side is opposite the 90 degrees is called the hypotenuse. It's going to be the longest side of the right triangle. Now the other two sides give us our final term for the right triangle, and that is leg. A leg of a right triangle is just one of the sides that's not the hypotenuse. In other words, it's one of the sides that forms that 90-degree angle. So don't forget those terms as well. When we're looking at the other classification, we are looking at the side lengths. And they might tell you here that a triangle is equilateral, isosceles, or scalene. We're going to start with scalene because that's the broadest. In a scalene triangle, none of the angles are congruent. So none of these have an equal measure. But when you get to an isosceles triangle, what you're going to end up with are two equal side lengths. And by the way, that's another thing with scalene to keep in mind. You can talk about the angles for scalene triangles, but since we are discussing the side length, all of the side lengths on a scalene triangle are also going to be different. Now with this isosceles triangle, we're going to get a few more terms as well. We end up talking about the vertex. Now technically each of the points are vertices, but when we look at the vertex, it's going to be the point that is at the intersection of the two equal sides. So here, this is our vertex. And opposite the vertex is going to be what we call the base. And the base is just that non-equal side is going to be your base. So even if this ends up being a sideways triangle, like let's say I gave you guys this as your isosceles triangle, the vertex is still here, and the base is still here. Even though it doesn't look like it's on the bottom, it's still that non-equal side. Last but not least, we have an equilateral triangle, and in an equilateral triangle, all of the sides are equal. We're also going to find out that all of the angles will also be equal, and each of those angles is going to be 60 degrees. That brings us to triangle formulas. And when we're talking about triangle formulas, the first one that we're going to talk about is the most basic, and that's the triangle sum theorem. In the triangle sum theorem, we find out that if you add all of the angles together in a triangle, they're going to equal a specific degree. And you guys can actually find this simply by making your own triangle. Rip off two of the corners of your triangle, and you can actually fit these corners in against the last one so that it forms a straight line. So I have to turn these around a little bit, but if you fit them in, see how this triangle's moved vertices end up forming a straight line or a straight angle. That means together all three of these have to equal the same as a straight line in measure, and that is 180 degrees. So just by taking a picture and ripping it up a little bit, you guys can actually do math. And if you ever forget, you can just find that formula yourself. But you can fill it in here so that you know that all of these will add up to 180 degrees. And of course, we can use that to solve for missing angles in a triangle. So here, in this triangle, if I want to find this angle, I can set up my formula. Each of the angles together, and I'm just going to call this one measure of x, when added should equal 180. So that gives us this formula. Here, we're going to simplify first, so we get x plus 125, or 55 plus 70, is equal to 180. Subtract your 125 from both sides to get x by itself, and you end up with x is equal to 55, or 55 degrees. And of course, you can double check your answer simply by adding these all together. It should give you a measure of 180. We can set up a similar formula here. Now notice we have an x that we want to solve for. And if I have a number that's unknown, but I know that it forms the interior angles or inside angles in a triangle, I can add them all together to get 180. Again, I'm going to simplify and solve. 38 plus 2 is 40, and then x plus x is 2x. Subtracting 40 from both sides gives me 2x is equal to 140. And that means that x itself, when you divide by 2 from both sides, is 70 degrees. And you can put that in and double check that when you add them all together, it does equal 180. For our next theorem, we have the AA triangle similarity theorem. And this one tells us that if two angles of one triangle are congruent to two angles of another triangle, the third angles will also be congruent. In other words, if A is congruent to D, and B is congruent to E, C will have to be congruent to F. Now this makes sense. I know that if I took the measure of angle A plus the measure of angle B plus the measure of angle C, it would equal 180. And the same is true of the other triangle. Measure of angle D plus measure of angle E plus measure of angle F equals 180. Now since they're equal to 180, according to transitivity, they have to be equal to each other. So I'm going to shorthand this. I'm going to do A plus B plus C is equal to D plus E plus F, right? Because they're equal to the same thing. Here, A and D are equal. So if I subtracted A from both sides, it would cancel it out, and I'd be left with B plus C is equal to E plus F. And I know that B and E are equal. So those two would cancel out. So I'm left with C would be equal to F in measure. Now that's the proof, but really you can just go ahead and use that rule. If you see two angles are congruent in triangles, you know the last angles will also be congruent. So here, if I was given the information that in this triangle we had this angle is equal to 56 degrees, let's say that was told to me. Well, when I look over, I know that this and these two angles are congruent. I also know that these two angles are congruent, which means that if I wanted to find this one, well, I can conclude that this angle is congruent to this angle. So that means that x here, this final angle, would also be equal to 56 degrees. And sometimes they'll do this and they won't even give you all of the markings. And they might just say, well, what angles do you know are congruent? Well, here I know that angle marked with 81 is congruent to this one because, hey, they have the same measure. I also know according to vertical angles that these two angles would have to be congruent because they are vertical angles. And last but not least, because two angles are congruent to each other, that means that final angle would also be congruent to each other due to the AA triangle similarity theorem. Which brings us to our final part in triangles for today, and that is interior and exterior angles. And these will give us just a couple more formulas to work with. First off, we need to know what these terms are. An exterior angle is an angle that forms a linear pair with one of the angles inside the triangle. In other words, this angle here, D, is an exterior angle. Because if you look at it, that angle forms a linear pair or a supplementary angle to angle B. We also have another term, and that is remote interior angles. Remote interior angles of an exterior angle are the two angles of the triangle that are not adjacent to the angle. In other words, if I wanted to find the remote interior angle of our angle D, it will be the two angles inside the triangle that are not the one that it is adjacent to. So that's going to be A and C. And you guys can do this with any exterior angle of a triangle. So for instance, if I took a triangle, I can actually draw out all of the exterior angles simply by extending one of the sides, and we tend to do this in like a pinwheel direction. So you end up with these. And the exterior angles are going to be the smaller of the two angles formed. You can see that you technically have also like a straight line with each of them. We're going to ignore that. The exterior angle is just going to be that smaller angle on the inside. And each of these exterior angles then have remote interior angles associated with it. So if these angles are 1, 2, and 3, the remote interior angle of angle 3 would be 1 and 2. It'd be the two angles that are not attached. And the remote interior angle of angle 2 would be 1 and 3, because those are the two angles that are not attached to this exterior angle. And of course, for the last one, the same concept is true. The remote interior angles to angle 1 would be 3 and 2, or 2 and 3. Now, there ends up being a quite nice pattern here. First off, you know that an exterior angle plus its interior angle, so in this case B, will be equal to 180 degrees because they are a linear pair. So that means, according to this one, D plus B equals 180. But we also have another pattern here. Notice that since they both are equal to 180, like this whole thing is equal to 180, I also know that this interior angle B plus A and C would give me 180. So that means that A and C together would have to be equal to D if I'm adding them to get 180. So what I could actually say is that my exterior angle D is going to be equal to the sum of my remote interior angles. So your exterior angle is always equal to the sum of your remote interior angles. And that's where we get the D is equal to A plus C formula. So those are going to be the two formulas you use with exterior angles. Let's try these out. So if I want to find x, I can use what I know about exterior angles to say that the exterior angle is going to be equal to the sum of its remote interior angles. Therefore, x is equal to 63 plus 86. In other words, x is equal to 149 degrees. And you can also solve this by solving for this angle and then solving for x using the idea that they are a linear pair. This is just the quicker version. We can also solve for P here by finding the interior angles of the triangle. Since this forms a linear pair with its interior angle, 130 plus this value will give me 180. So that means that this has to be 50, because 130 plus 50 is equal to 180. I can do the same thing here to find the interior angle that is adjacent to this exterior of 110. And that tells me 110 is equal to, plus my interior angle is going to be equal to 180. Subtract 110 from both sides, and I know that this will be 70 degrees. I can use this to solve for P by saying 50 plus 70 plus P is equal to 180, because the sum of the inside of a triangle will equal 180. That tells me 120 plus P equals 180, or P is equal to 60 degrees. For this one, again, I notice I have an exterior angle and two remote interior angles. This is going to give me the following formula. My exterior angle is equal to the sum of my interior angles. Here I'm going to do a little bit of algebra. And this is the result.